Alright guys, so in the last video we finished section 3.2.3, the activity and all the workbook questions. In this video we'll be solving all the section 3.4 activities, and then we'll also move on to the additional exercises for the workbook that is also mentioned in the revision sheet. The grid questions, I think the answers are on the web, so I won't be solving them. Anyways, so for activity number one, this is all about the chain rule, right? So I'll explain what it is first. If you have a function f of x, this is equal to g of h of x. What do I mean by that? We mean by a function composition. For example, let's say that you have f of x is equal to the square root of x squared plus 1. We can split this function into two parts and put one into another. So let's define g of x is equal to the square root of x, and h of x is equal to x squared plus 1, right? So what is g of h of x? That's g of x squared plus 1, right? This is equal to the square root of x squared plus 1, which is equal to f of x. So in this case, we have a thing called function composition. It's also written as g rho h of x, but doesn't matter. Anyways, how do we find the derivative of such kind of functions? There's something called the chain rule, and it's called the chain rule because you can add like more function compositions into each other, like chain them up together. But in this case, we'll just deal with two functions. Anyways, let's erase all this. How do we find the derivative? Let's set this equal to y. So we want to find dy over dx. How do we do it? Let's simplify this notation a bit. Let's say that this is equal to g that depends on h, right? And h, in turn, depends on x. So if you want to find the derivative of y with respect to x, let's find the derivative of y with respect to h. Then we find the derivative of h with respect to x, right? And then we chain them together, we multiply them together. And you can see algebraically, you kind of can cancel the dh out and you will end up with dy over dx. So it kind of makes sense, right? We want to find how y changes with h, and then find how h changes with x, then you multiply them together. Anyways, now that you have the idea of the chain rule, so let's solve part A. Let's see, part A, we have y is equal to 5x plus 2 all to the power of 5, right? 3 is a constant, so leave that on the side. So dy over dx is 3 into something, right? Leave that on the side. So what are the two functions here? We have g of x is equal to x to the 5, and then h of x is equal to the inner function, this inner function, which is 5x plus 2. So even though you know the theory behind it, like this, but how do we actually apply it to a specific example? An easy way to do it is you treat this inner function as some variable, u, for example, and then we take the derivative with respect to u, okay? So it's 5u to the 4, right? And then replace u with the thing, so it's 5x plus 2, right? And then we find the derivative of the inside. We find the derivative of u with respect to x, so multiply by 5. Let me do it again. So y is equal to 3 into 5x plus 2, 5. So dy over dx is leave 3 on the side, right? Get the inside, set it to u, right? We want to find dy over du, so that is 5u to the 4, so it's 5u, which is 5x plus 2 to the 4, times the derivative of u with respect to x, which is 5. Evaluating this gives 3 times 5 times 5, that is 75, 5x plus 2 to the 4, that's dy over dx. If you didn't understand, don't worry, I'll do more examples, you will understand later. So B, we have y is equal to x squared minus 6x all to the power of negative 10, right? So how do we do it? We want to find dy dx, right? Set the inside to some random variable u, and then we find dy with respect to u, and then u with respect to x, right? This is the same thing here, I just wrote two different variables. Anyways, so what's dy over du? So we treat it as u to the negative 10, right? So bring negative 10 down, u to the negative 11. So we have negative 10. What's u? U is x squared minus 6x to the negative 11. And then we want to find du with respect to dx, right? So u is this. With respect to x, we'll find that to be 2x minus 6. Simplifying this gives negative 20 into x minus 3 over x squared minus 6x to the power of 11. So that's B done. Let's do C. For part C, okay. Y is equal to the square root of 1 plus 3x squared all to the 5, I think. Yeah. So how do we do this? We know that if y is equal to square root of x, y prime is equal to 1 over 2 radical x, right? So that means y prime here will be 1 over 2 radical all this, which is all of the inside, right? So 1 plus 3x squared to the 5. However, we found, well, in this case, dy over du, right? We still have to multiply du over dx. So that means the derivative of the inside, this, sorry, didn't mean to do that. This, we need to find the derivative of the inside. What's that? We need to apply the chain rule again. So we have two chain rules here. We chained it twice. So we multiply by 5. What's the inside this case? This case it's 1 plus 3x squared to the 4. And then the inside, the derivative of the inside is 6x. So in this case, we basically did dy over dx is equal to dy over du times du over some other variable, I don't know, v, times dv over dx. So we did two chain rules. Anyways, simplifying this gives y prime is equal to 15x into 1 plus 3x squared all to the 4 all over radical 1 plus 3x squared to the 5, right? We can simplify this a lot. Let's see. We can rewrite this as 15x into 1 plus 3x squared to the 4. See, instead of writing this, I'll write 1 plus 3x squared to the 4 times 1 plus 3x squared, right? Splitting the radical, this gives 1 plus 3x squared times radical 1 plus 3x squared. Lots of stuff will cancel out. This will give 15x 1 plus 3x squared over square root of 1 plus 3x squared. Now this is equal to 15x. So we have 2 minus half, right? Which is 1.5, which is 3 over 2. So instead of writing 3 over 2, I'll write the square root of 1 plus 3x squared cubed. That's the derivative. If at this point you still don't understand how to apply the chain rule to different functions, I recommend you to go watch one of our other videos made by Amro. He made one video for the chain rule, and product rule, and quotient rule. Go watch it, it will help a lot. Anyways, number 2, we have chain rule again. So number 2a, y is equal to 3x plus 1 to the 6th plus 6x squared minus 5x, right? This is equal to 6 into 3 plus 3x plus 1 to the 5 times the derivative of the inside, which is 3, plus 12x minus 5. This is equal to 18 into 3x plus 1 raised to the 5th plus 12x minus 5. That's your answer. Part B, we have y is equal to negative x4 plus 2x plus 5 plus 6x. So y prime is equal to negative 4x to the 3, 1 over radical 2x plus 5. Apply the chain rule here, okay? This is a plus, and then plus 6. Now for part C, I think we need product rule here. Nice. Y is equal to x into x squared minus 1 to the 4. Now, product rule states that if you have a function f of x, which is equal to u of x times v of x, then f prime of x equals to derivative of the first times the second plus keep the first, derivative of the second. That's how Mr. Dia does it, and I think is the best way to do it. Anyways, so that means y prime is equal to derivative of the first, which is 1, keep the second. So x squared minus 1 to the 4th. Plus, keep the first, x into derivative of the second, which is the chain rule. It's 4 into x squared minus 1 times 3, to the 3, times 2x. This is equal to x squared minus 1 to the 4 plus 8x squared into x squared minus 1 to the 3. Now we can factor out, so x squared minus 1 to the 3 into x squared minus 1 plus 8x squared. Now we have x squared minus 1 to the 3 into 9x squared minus 1, and that's your answer. Part D. Product rule again, we have y is equal to x squared plus 1 into x squared minus 1, radical x squared minus 1. Now, y prime is equal to derivative of the first, which is 2x times the second, plus keep the first, derivative of the second is 2x over 2 radical x squared minus 1. 2 is cancelled out. And let's simplify this. Let's rearrange this a bit. So we have x into x squared plus 1. And let's multiply up and down by radical x squared minus 1. So this will remove the square root. And then let's combine the fractions. So 2x into, what's this? This is plus 1. Okay, x squared minus 1 plus x into x squared plus 1 all over radical x squared minus 1. Now let's distribute. We have 2x cubed minus 2x plus x cubed plus x all over radical x squared minus 1, which is equal to 3x squared minus 3x cubed minus x over radical x squared minus 1, and here's your answer. Now, 3. A, we have y is equal to x squared over x squared minus 1. Let's see, this is a quotient rule, so we apply the formula, so y prime is equal to, draw a line, x squared minus 1 squared, derivative of the first, which is 2x, keep the second, x squared minus 1, minus, keep the first, x squared into 2x. This doesn't have any chain rule in it, so it's easy. So let's distribute. We have 2x cubed minus 2x minus 2x cubed, all over x squared minus 1 squared. This is equal to minus 2x over x squared minus 1 squared. And here's your answer. Part B, we have, y is equal to x cubed over radical x cubed minus 1. Let's see, this is quotient rule with chain rule, so y prime is equal to x cubed minus 1, 3x squared radical x cubed minus 1 minus x cubed. Let's see, we have a 3x squared over 2 radical x cubed minus 1. I apply the chain rule here. Now, this x cubed is in the numerator, so be careful. Okay, let's simplify. This is hectic. Let's do it. Okay, 3x squared into radical x cubed minus 1 minus 3x to the 5th over 2 radical x cubed minus 1. All of this over x cubed minus 1. Now, let's multiply up and down by, for this part only. Let's multiply up and down by 2 radical x cubed minus 1. So this will get rid of that. Over 2 radical x cubed minus 1. Now combine the fractions. We have and distribute. So we have 3x to the 5th minus 3x squared minus 3x to the 5th all over 2 radical x cubed minus 1. Sorry, I did a mistake. I need to multiply by 2 here. So this becomes 6x to the 5th minus 6x squared minus 3x to the 5th. Yeah, and then we have this all over x cubed minus 1. Now let's simplify. Let's bring this here. This is equal to 3x to the 5th minus 6x squared over 2 into x cubed minus 1 radical x cubed minus 1. And I think we're done. This is the final answer. This was some really bad algebra here. So we're done with the chain rule, and now we're in the extra workbook questions. And since they mentioned that we have extra exercises, those will probably come in written. Okay, along with, let's see, section 3.1.4, activity 2, number 234. Those 3 questions, plus those 2 questions over here, I think they're coming in written. So, number 6. Let's read. The equation of the curve is y equals to x squared minus 4x plus 6, and the equation of the line is y plus 2x equal to 9. The curve and the line intersect at the points A and B. Now, the midpoint is M. Find M. Find the coordinates of the point Q on the curve at which the tangent is parallel to the line y plus 2x equal to 9, and then find the distance MQ. This question is not that bad, to be honest, so let's write the given down. So the curve, and for the line, we have y is equal to minus 2x plus 9. So for part A, we need to find the midpoint of AB, right? And the points A and B are where they intersect. So they intersect means we need to equate them. So x squared minus 4x plus 6 is equal to minus 2x plus 9. Again, if you have no idea what I'm doing, I recommend you to watch, I think, part 2 and 3, where I did the harder exercises. Anyways, equating this will give us x squared minus 2x minus 3 is equal to 0. Factor, so x minus 3 into x plus 1 is equal to 0. That means x is either equal to 3 or x is equal to negative 1. That means that you have the point A and you have the point B, and let's see, they intersect at A and B, right? So we have A is 3 something and B is negative 1 something. We substitute 3 into either the curve or the line. We get, let's see, we have 3 and 3, and then negative 1, we have 11. So here are the 2 points A and B, and they asked us to find the midpoint. So the midpoint is 3 minus 1 over 2, and then 3 plus 11 over 2, which is 1, 7. So we verified that the midpoint is indeed 1, 7. Now for part B, the coordinates of the point Q on the curve at which the tangent is parallel to the line y plus 2x equal to 9. So what does it mean parallel? Parallel means same slope, right? And they said that the tangent has the same slope as the line. That means that the slope of the tangent is equal to -2, right? What's the slope of the tangent? Is the derivative, right, of the curve at x is equal to, that's what we need to find, right? We need to find the coordinates of the point Q. So x is equal to, I don't know, Q sub x, right? So we need to find the derivative of the curve. So y prime of the curve is equal to 2x minus 4. And then let's evaluate. So y prime curve at x is equal to Q sub x is equal to, well, 2 times Q sub x minus 4. And this needs to be equal to -2, right? Solving for Q sub x is equal to 1. That means the point Q is 1 comma something. Now, they said that this point is on the curve. So substitute 1 on the curve, we get 1 minus 4 plus 6, which is 3. So Q is 1, 3. Right, so we found Q, and then we need to find the distance MQ. We found M before, and now we found Q. And we noticed that their abscissas are the same, and their ordinates are different. So that means the distance MQ is equal to 4 units in this case. Now for question 7, equation of the curve is y equals to 7 minus 9 over x. So for the curve, this is number 7, y is equal to 7 minus 9 over x. Show that the equation of the normal to the curve at the point P is x plus y equals to 7. This normal means the curve again at the point Q. Okay, we need to find the normal, right? Finding the normal means finding the tangent and then change the slope somehow. So what's the tangent? So we need to find y prime, which is the slope of the tangent, which is equal to 9 over x squared. Now we need to evaluate it at the point P, right? So x is 3. So evaluating this, y prime, x equal to 3, this gives us 1. So that's the slope of the tangent, right? That means that the slope of the normal is equal to -1. It's the negative reciprocal. That means the equation of the normal is y minus y0 is equal to -1 x minus x0, and they set the point P, right? So y minus 4 is equal to -1 to x minus 3, so that means y is equal to negative x plus 3 plus 4, that means y is equal to negative x plus 7. Rearranging this gives us x plus y is equal to 7. And we verified it, and it's true. So, and then they gave us this information. This normal meets the curve again at the point Q. So that means they meet. That means we need to find their intersection. How do we find that? We set them equal to each other, right? So we have y is equal to negative x plus 7, and then we have the curve, which is y is equal to 7 minus 9 over x. Set them equal to each other. We have negative x plus 7 is equal to 7 minus 9 over x x is equal to 9 over x squared equals to 9. X is equal to plus or minus 3, right? Which one do we choose? They said that show that the equation of the normal to the curve at the point P, whose x value, so P sub x is equal to 3, right? So this normal passes through the point P, right? Whose x value is 3. They said that the normal meets the curve again at some other point Q. That means we choose -3 in this case. That means Q sub x is equal to -3. They said to find the coordinates of Q, right? So we know that it's on the curve, right? Q is on the curve. That means we substitute. So that means Q sub y is equal to, well, 7 minus 9 over minus 3, which is 7 plus 3, which is 10. So Q is -3, 10. That's part B done. Part C, find the length PQ. This should be easy. We have the points P. Point P is 3, 4, and point Q is negative 3, 10. Distance formula or Pythagoras theorem, they're the same thing. Let's see. So PQ is equal to 6 squared plus 6 squared, which is equal to 36 plus 36, that's 72. Radical 72, which is 6 radical 2, and then unit, whatever unit it is. So, we finished 6 and 7. Those will probably come in written, as I said before, so make sure you know them. And still, if you still don't understand, me and Hassan, we're hosting a math session tomorrow, or today if you're watching it. I don't know when you're watching it, but on Saturday from 11 to 1 in the grade 12 corridor in ISC Sharjah. So if you have any questions, or even if you're not in ISC Sharjah, if you're from like ISC Dubai or something, then please come and ask us your questions there. Anyways, that should be it for the math revision sheet. And as always, easy.